This is Max Headroom, and what you're about to witness is one of the most sinister-sounding intros to a trailer to one of the greatest epics ever produced in the history of television. And there's more, because you are going to see it as well.
Yes, it.
Yes, it. Yes, namely...
Perfect squares. Today we're going to learn about perfect squares in our algebra class. So let's get on with it, because I will be your virtual teacher today.
So let's get started. All right. What are perfect squares? Well, let's see. The thing we're squaring in each equation, what expression could be substituted for a? All right, so we're substituting something for a. So the equation is true for all values of x. All right, let's look at this first. X squared has to equal a squared. Well, obviously in that case, a has to equal x. Ooh, there we go. Focus in there. A equals x. So x squared would equal x squared. Now on this next one, 3x squared would equal a squared. Well, again, obviously it must be 3x, because then 3x squared would equal 3x squared. Bring it in a little closer, make it a little bit bigger. Oh, that's a little better. All right. A squared equals 7x times 7x. Well, this is just rewriting 7x squared, right? It's the same thing as 7x times itself, 7x squared. So if a squared equals 7x squared, a must equal 7x. It's just putting it in a different form to try to throw us off. Okay, this one says 25x squared equals a squared. Your first thought might be it's 5, right? Because 5 squared would be 25. But if we just put 5, it would just be 25. 5 squared would be 25. 25x squared does not equal 25. It would equal 5x squared, right? Because x times x and 5 times 5. So a must equal 5x. Don't forget the x. Okay, this one we've got a squared equals 1/4 x squared. It's kind of like this one, except we're using a fraction now. So what fraction multiplied by itself is 1/4? Well, dealing with fractions, remember when we multiply, we just multiply straight across. So 1 times, let's say we're multiplying, 1 times 1 would equal 1, but what times itself would equal 4? So it must be 1/2 times 1/2 equals 1/4. So this, in this case, a must equal 1/2 x, because that's what you would square to get 1/4 x squared. And fractions aren't that bad. Just know the rules. Multiplying goes straight across, and it's not too hard to get there. So in this, a squared would equal x plus 1 squared. Well, a must equal x plus 1, because that would make it the same as this. Excuse me. 2x minus 9 times 2x minus 9 equals a squared. Well, this is just like this, right? Multiplied by itself would be the same as 7x squared. So this is the same as 2x minus 9 squared. So a must equal 2x minus 9. Okay, those aren't so bad. This is what the thing we're squaring. These are what we're doing to square things. So let's look at perfect squares in different forms. So this is, each expression is written as the product of factors, right? This is 3x times 3x, because it's 3x squared. This is 7x times 7x. It's the product factor. So write an equivalent expression in standard form. Okay, standard form, that's when we do all the multiplication. We do the distributive property when necessary. We get rid of any parentheses. It's just finalized in standard form. So what is 3x times 3x? Well, 3 squared, 3 times 3 is 9. X squared is x squared. So that is an equivalent expression, because that would be 3x times 3x. right? 3 times 3, x times x, 9x squared. This one's already written out in a nice way, 7x times 7x. We don't have to deal with rewriting it from that. So that would be the same as 7 times 7, 49, x times x, 49x squared. I'll put a little equals up there too. Okay, now we've got a little different. We got the binomials. Binomials 2, remember? So this has 2 terms. Bi is 2. X plus 4 times x plus 4. Remember, when we do that, we have to distribute. The x has to go to the x and to the 4, and the 4 has to go to the x and the 4. Now remember, you can always use the box method if this confuses you, where we've got the 4 boxes, and we have the x and the plus 4, and the x and the plus 4. I put the plus there if it helps you there. X times x is x squared. X times 4 is 4x. X times 4 is 4x. 4 times 4 is 16. So that would give us x squared plus 4x plus 4x plus 16. Ooh, going off our page here. All right, we just take all of those and add them together. So this like terms, we see like terms there. So this would be the same as x squared, 4x plus 4x, and then the plus 16 at the end. So x plus 4 times x plus 4 is the same as x squared plus 8x plus 16. And do you see the relationship there? You see what happened? We had a 4. Let me highlight this just so we can see this. We had a 4, and it was being multiplied by itself. So what happened was we took the 4, multiplied by itself to get the constant. But then each of those 4s multiplied times an x at some point. The outside one, see this one multiplied by this x, and this one multiplied by this x, which just ended up with 2 of them. So if we take the 4 and we add it together, 4 plus 4, that gave us the 8x. So that gave us the middle term. So knowing that shortcut, when you have the same binomial being multiplied by itself, that gives us, we don't necessarily have to do this if we understand what's happening, that to get the constant, we're just multiplying them together. And to get that middle term, we're adding the same number twice. So this one, using the same rationale, the middle term would be the same number twice, 1 plus 1. So we would have 2 x's in the middle, and 1 times 1 would give us a plus 1 on the end. All right. We did this some when we were having different binomials. We had x plus 1, x plus 4, and then we would add those together and multiply. But it's even easier when we have the same number because we're just squaring it for the last number and just adding it together. X minus 7. Now we have to pay attention to the minus. This is a little bit different case, minus 7. So x squared, what's minus 7 plus minus 7? That means that middle term is going to be minus 14x, right? Because we have to keep the minus. But when we have minus 7 times minus 7, now we have a negative times a negative. We're going to have that positive 49 on the end because we always have a positive number when we multiply 2 negatives. Or when you square a negative. That's the same thing as multiplying by itself. Now let's get a little bit more abstract. Anytime x plus n, regardless of what n is, and it's just a variable, this would be the same as x squared. And what is n plus n? Well, that would give us 2n x's. Don't forget we have an x as the middle term. And the coefficient of the x is 2 n's. And then on the end, we take whatever n is and we multiply it by itself. So in general, we're looking at x squared plus 2nx plus n squared for any one of these. We could take the same negative 7, put that there. 2 times negative 7. So there's 2 of them, negative 14. Negative 7 squared, positive 49. And remember, if you're doing this in a calculator and you're doing negative 7 squared, you have to put that -7 in parentheses. Because if you don't, it's going to square the 7 and then put the negative on the front. And it's going to say it's -49, which is wrong. Right? It's not -49. All right, why do you think the following expressions can be described as perfect squares? Well, because they look lovely. They're absolutely, the numbers are crisp. No, that's not why they're perfect squares, all right? And they don't even look square if we're going by that definition. So, perfect squares. Well, what is the square that would give us 9? What roots, right? What are the roots of 9? Well, 3 times 3, that would work. And what is 3 plus 3? It's 6. So it's 3 plus 3 and 3 squared to give us the constant. Over here, we have -16 and 64. So let's go this route. If we took -16 and cut it in half, what number would be added to itself? Well, it must be -8 plus a -8. Well, what is -8 squared? -8 times -8. It's 64. Ooh, here's tricky. What is half of 1/3, or what number would be multiplied by itself to get 1/36? Might be easy to think of that one, right? Because if we go back to this method where we're saying 1/36, when multiplying fractions, you just multiply the top straight across and the bottom straight across. So what number multiplied times itself would give us 1? Obviously, it's 1 times 1 gives us 1. What number multiplied by itself gives us 36? Well, 6 times 6 is 36. So 1/6 must be the square root that gives us 1/36. So 1/6 plus 1/6. What would that be? Because that, if this is working like all the others, it should equal this, right? Well, when we add fractions, you have to have the same denominator, which we do. So you keep the denominator. If we have 1/6 and now we have another 6, we add the top. So we have 2/6. We can simplify that because we can divide it by 2/2, right? And dividing by 2/2 is the same as dividing by 1, right? Because 2 divided by 2 is 1. So 2 divided by 2 is 1. 6 divided by 2 is 3. So that's the same as 1/3. 2/6 is the same number as 1/3. So this also works that the same number that we square here, we add together twice to get that. So that's why those are perfect squares, because they break out into the same binomial. It'd be the same as x plus 3 squared, right? And this one would be x minus 8 squared, and this one would be x plus 1/3 squared. Because we can take a binomial, the 2-term expression, we can take a binomial and we can square it to get this standard trinomial, tri being three terms, right? So each of these trinomials can be broke down to a binomial that we square. So these are known as perfect squares. Fabulous. Let's look what the next page holds in store for us. Oh, we're going to start off with, are you ready for more? Well, let's see. Sometimes they get a little trickier on this, right? We're going to up our game a little bit. X to the 4th minus 30x squared plus 225. Don't let that throw you off, because that's just the same as x squared times x squared, right? X squared times x squared. So we're still in the perfect square category. We're just not using x squared to start with. We're using x to the 4th. So our middle term now, instead of being x, is x squared, because we're going to have 2 of those. So what number multiplied by itself would be 225? Well, let's go check this one. What number added to itself would be -30? Well, -15 and -15 would be -30. Is that what multiplies? Now, if you don't know that right off your head, let's pull up the calculator just to verify that that is the number. So if we do -15, negative, gotta put the negative after I put the 15 on this computer, times 15 negative. So I've got -15 times -15. It is 225. shows negative 15 times negative 15 equals 225. So that is the number we were looking for. So this is x squared minus 15 times x squared minus 15, or the same as x squared minus 15 squared. All right, let's look at this one. This we don't have an x squared, we just have an x. So what multiplied by itself would give x? Well, that would be the square root of x, because we don't really know what x is. It's just a variable. And our middle term has a square root of x, so that would indicate that we're on the right path. What number would multiply by itself to be 49, add together to itself to be 14? So that is the same as the square root of x. The kitty is demanding breakfast squared. All right. So far, so good. But what is going on here?
So we have x in our exponent this time. So we've got 5 to the 2x plus 6 times 5 to the x plus 9. So will that break out just as easily? Let's see. 5 to the 2x, what would multiply by itself to be that? Well, if we remember our rules of exponents, if 5 to the x times 5 to the x, remember we add exponents when they're multiplied together. So 5 to the x times 5 to the x would be 5 to the 2x. So we'll put 5 to the x and 5 to the x. And our last number is 9. So which number can we square and get 9? Plus 3. Does that work for us? 5 to the x plus 3 times 5 to the x plus 3. 3 times 3 is 9. 3 plus 3 is 6 5 to the x's. So 6 5 to the x's plus 9. And then our first one is 5 to 2x, because remember our rule of exponents says add those. So this would be equivalent. So that just breaks out to 5 to the x plus 3 squared. Looked tricky. Wasn't so bad if we remember our rules of exponents. Another tool in our bag we had to pull out. All right, let's skip down and see what else we got to do here.
Methods. Let's look at what Han and Jada did. Han and Jada solved the same equation with different methods. Now, this is an interesting way to do this, because this is another shortcut that we're going to see here, because both of these come up with the same answer. We see this is x is 11 or 1, x is 11 or 1. So both of these methods come to the same answer. And this is something you might like better than the way we've been doing this. So let's look and see what Han did. He had x minus 6 squared equals 25. So that'd be x minus 6 times x minus 6 equals 25, right? Because he just rewrote that. So then he took this and he distributed it to standard form. So since you have a minus 6 as both of them, you'd add it together to get the middle term, multiply to get the last term. So this is the same as that. Okay, then he subtracted the 25 over and set it equal to 0, so he can use the zero product property, right? So when you subtract 25 from 36, you get 11. So he took this and he broke it out into its factors, which ends up with negative 11 and negative 1. If we multiply negative 11 times negative 1, you get positive 11, because it's a negative times a negative. When you add them together, you get the negative 12. So these are equivalent. And so setting each of those equal to 0, if x minus 11 equals 0, the answer is x is 11. X minus 1 equals 0, the answer is 1. Okay, that's the way we've done that. But let's look and see what Jada did, because this is a little different. She said x minus 6 squared equals 25. So she said, so that means either x minus 6 equals 5 or x minus 6 equals negative 5. How did she do that? Well, what she did is she said, well, if this is a squared number, what number is this? It's 5 squared. Or she said it could be negative 5 squared, because either one of those two would be 25. So she said, if I take the squared away, so I take the square root of it, the square root of x minus 6 times x minus 6 is just one of the x minus 6s, right? Because you'd multiply by itself, and that would be squaring it to get back to there. The square root of 25 is either 5 or it's negative 5. So this is another way to do this. If you can take this number and break it into the two possible square roots that it has, either x minus 6 equals 5 or x minus 6 equals negative 5. So if it equals 5, when you add 6 to both sides, 5 plus 6 is 11. On this one, when you add 6 to both sides, negative 5 plus 6 equals 1. It's a shortcut. It didn't require nearly as much work as this did. First, we had to distribute and find the standard. Then when we moved that over, we had to take the standard and go back to the factored form just to get to the answer, where Jada took a shortcut here. So let's look at these bottom ones. It says, work with a partner to solve these equations. Well, the cat has left. I guess I'm on my own. So for each equation, one partner solves with Hans' method, and the other solves with Jada's method. Make sure you get the same solution to the same equation and not work together. Anyway, I'm going to do these with Jada's method because we've looked at Hans' method a lot. We're going to do this, and then we'll do one of them with Hans' method just to kind of show they are the same thing. So her method said take the square root of both sides. Well, the square root of that is y minus 5, because that would just be one of those. When you square something, you square root it, it's the opposite of squaring. 49 is either 7 squared or it's negative 7 squared. It has to be one or the other. So either y minus 5 would equal 7 or y minus 5 would equal negative 7. Right? Add 5. Got to do it to both sides of the equals. So y equals 7 plus 5, 12, or y equals negative 7 plus 5, negative 2. That was a lot quicker than using the method that we knew before, which Han was using. Let's do the same thing over here. X plus 4 equals 9 is either 3 or negative 3, right? So that would equal 3, or x plus 4, move that over a little bit, would equal negative 3. So we'd have to subtract 4. So x equals 3 minus 4, negative 1, or minus 4 minus 4. X equals negative 3 minus 4 more. So x either equals negative 1 or negative 7. That's the two solutions for that equation. Fractions. Again, fractions aren't a big problem. If we just know the rules. 4/9. What number would multiply times itself to be 4/9? Well, if you want to go back to the method I was showing you earlier, we know that in multiplying fractions, you just multiply straight across. So what number would multiply by itself to be 4? That must be 2 times 2. What number would multiply by itself to be 9? 3 times 3. So this must be 2/3 or negative 2/3, right? Either one of those would multiply by itself to be a positive 4/9, because either positive times a positive or negative times a negative. So not x. I'm trying to write an x. They got me in the habit of that. Z plus 1/3 equals 2/3, or z plus 1/3 equals negative 2/3. Okay, so we would subtract 1/3 because that's what's with the z, and we want to get the z by itself. Subtract 1/3. We'll do that over here also. So what's left? Z equals 2/3 minus 1/3. Well, now we only have 1/3 left, right? On subtracting, you have the same denominator, which we do. So you just subtract the top numbers, 2 minus 1, 1/3. Or z equals negative 2/3 minus another third. So keep the denominator, which is 3, and we subtract the top. Negative 2 minus 1 more is negative 3. So negative 3 over 3, that's the same thing as negative 1. So z would either equal 1/3 or negative 1, which is negative 3/3. Same thing. Okay, let's look at this last one. V minus 0.1 squared equals 0.36. So what number would multiply by itself to be 0.36? Well, we know 6 times 6 is 36. So let's see, does 0.6 times 0.6 equal 0.36? We've got to figure out, is it 0, 6? Is it just the 6? So knowing the rules of that, so 6 times 6 is 36. And since there's 2 decimals, we've got to move 2 decimal points, 0.36. All right, 2 decimal points. So this is either 0.6 or it's negative 0.6. We have 2 answers, so don't forget the negative. So either V minus 0.1 equals 0.6, or V minus 0.1 equals negative 0.6. Now 0.6 is the same as 0.6. We can put as many zeros as we want in front of it. It doesn't change the value. So we would add 0.1. So what is 0.6 plus 0.1? V would equal 0.7, or negative 0.6 plus 0.1, V would equal 0.5. If that's a negative, that's a positive. Okay, see how that all worked? Worked real nice. A lot easier and shorter, but let's take this first one. Now let's take this one here. Let me get a blank sheet of paper, and we're going to give some room to do Hans' method on that. X plus 4 squared equal, oops, sounds like someone's at my front door, 9. Okay, so what we need to do first is we'll rewrite that as x plus 4 times x plus 4 equals 9. Then we need to distribute that. Now this is one of those, we can use a shortcut. It's the same number twice. So it's x squared, 4x and 4x, right? We add the number to get the middle term, 4 plus 4, and we multiply it to get the last term. Okay, so we've got x squared plus 8x plus 16. Now we need to, let's see, what did Han do next? When he got it to that point, then he set it equal to 0. So we need to move our 9 over. So we'll subtract 9 from both sides. So our new equation is x squared plus 8x. And then 16 minus 9 is plus 7 equals 0. So we have it equal to 0. So now we need to break this out into 2 binomials. All right, so we can use the 0 product property there. So this would be x and x, and we need 2 numbers that would multiply together to be 7 and add together to be 8. Well, 7 only has 2 factors, and they are 1 and 7. That's the only numbers we can use to multiply together to be 7. So when we have the 1 and the 7 added together, we do get 8. And when we multiply them together, we get 7. So this is the 2 factors. So x plus 1 would have to equal 0, or x plus 7 would have to equal 0 for that to equal 0, right? If this is 0, it doesn't matter what that is. It's going to be 0 because we're multiplying together. Or if this one's 0, it doesn't matter what that is. When you multiply them together, it's going to be 0. So if either one of these is 0, that equation will be true. Subtract 1. Subtract 7. So x equals negative 1. X equals 0 minus 7, negative 7. What answers did we get up here? Negative 1, negative 7. So there is another method you can use when you're dealing with perfect squares. Right, so those are perfect squares. You have the same binomial multiplied by itself, and you can take the square root of the other side, which, don't let it fool you. We were able to do that with 4/9. We were able to do that with 0.36. We were able to find numbers that we could square and do that. So when you have numbers we can square, perfect squares, then you can use this shortcut. When you don't, you gotta kind of work this out. When we get down to here, x plus 1, x plus 7 is not perfect squares. This one was not perfect squares, so we had to use this method. But if you like that, I like that. It's a lot easier, a lot shorter. That will give you something to work with and practice. So today's assignment will be problems like that. There'll also be probably a question or two from what we've learned before. So don't let that mess you up. But I will have this online, and I will be online. Let's see, tomorrow. I'm looking at Wednesday and Thursday. I am trying to do some afternoon times because that seems to work better for some students. I've talked to students that have like a whole bunch of morning teachers. So I think I'm going to try like 12:30 to 2 on today and tomorrow, Wednesday and Thursday. So let's try 12:30 to 2. I'll update that on Google Classroom to put those times there if you don't remember. And then Friday is like tutoring day. We will not have a lesson on Friday. We'll have lessons, a Monday, Tuesday lesson. We'll have a Wednesday, Thursday lesson, whichever day your class meets. And then Friday will be a tutoring day where you can get online. You can email me for an appointment time, or I will have a big block of time that I'll post on Google Classroom. I'll be on several hours that you can hop on and get help with anything we're working on if you're stuck on it. And when you do these assignments on Go Formative, I set them to allow you multiple attempts. You can go back and redo things. If you do something and you mess up, and you're like, oh, I know what I did right. What I did wrong, I can do that right now. Go back and redo it. I've set it to allow multiple attempts because this is your practice. I want you to understand this. I don't want you to get it wrong. Go, okay, I don't know what happened. Write it down. Email me or hop online with me or with Mrs. Smith and figure out what you did wrong so you can go back and make sure you understand how to do this. Trying to help you all we can. I know it's a little different staring at a computer screen rather than being able to talk to us in person, but that's why we're hopping on the video chats every day. So we're there for any questions you got, or if you just want to say hi, hop on. Always happy to see you. So that's it for today. We'll see you next time.